Hi everyone, this is Mrs. Sykes, and today we are going to have a look at the idea of enzymes. Now, an enzyme is a chemical that is found inside every single one of your cells, and there are lots and lots of them inside every single one of your cells. And their job is to speed up chemical reactions. Now, in your body, loads and loads and loads of chemical reactions take place. And some of them would happen anyway if we didn't have any enzymes. But they wouldn't happen quickly enough for us to stay alive. So enzymes are absolutely necessary for us to be alive. This bit here is the enzyme. So all of this section here in this picture is the enzyme. But only one part of it is really important. And this is the bit that I've done in red. This is called the active site. And the active site, the mouth shape bit, if you like, is the bit where things fit or don't fit. Over here, we have got something called the substrate. The substrate is what goes into the enzyme. Now, most of the time when you come across enzymes at GCSE, it will be in terms of digestion. So your enzyme will break some food down into smaller bits. So for all intensive purposes, when you're looking at digestion, the substrate is the food. So this is a protein molecule. The protein goes into the active site of protease, and the protease enzyme breaks down the protein into smaller bits, in this case called amino acids. So the substrate is the bit that goes into the mouth to be broken up into smaller pieces. This active site and this substrate match each other in terms of shapes. They're complementary, like a hand and a glove. If they don't match, then they don't work. So for example, if this is protease, if I tried to use something else, like starch instead, starch is a different shape. Because it's a different shape, it won't fit into the active site. So it can go into the active site, but nothing will happen. So it wouldn't be broken down by our enzyme. This is why enzymes are called specific. Only the right substrate will fit into the active site, so only those will go together. Protein is what makes up an enzyme. So this protease enzyme is also made up of protein. So because it's made of protein, it means that it's sensitive to heat. So if you heat it up, it breaks. It's called denaturing. So if I have this enzyme and I have heated it, then it melts, a bit like a Kit Kat that you've left in your pocket accidentally. And because it's melted, it's lost the shape of its active site. And if the active site has changed shape, it is called denatured. And when it is a different shape, the original substrate can't fit in there anymore. And if it can't fit in there anymore, it doesn't fix it. And this is the same for if you have a Kit Kat in your pocket and it melts, but you keep it in the wrapper and you go, I know, I'll put it back in the fridge. It never goes back the way it was before. If you take an enzyme and you heat it to, let's say, 170 degrees Celsius, it will denature, it will melt. And this active site will change shape. If you then cool it back down again, and you cool it down to a very sensible 25 degrees Celsius, it's still the wrong shape. It hasn't automatically unmelted itself and put it back into the right sense. So once things are denatured, they stay that way, which is why we often boil food, things like milk, pasteurisation, that we want to stay fresh, because even when you've cooled it back down again, it doesn't start to react anymore because the enzymes are still broken because they have been denatured. Denatured means broken, it doesn't mean dead, because these are so little, much, much smaller than a cell, they were never alive in the first place. So when they get heated up and they go bleh, and don't work anymore, it's because they are denatured and the active site doesn't work anymore. So enzymes speed up chemical reactions in our body. If you had an experiment, for example, you might have an experiment with a little test tube like this, and you might have a couple of bubbles. If you added an enzyme, it would be much quicker and there would be much more reaction taking place. So it's easy to tell if an enzyme's worked because the reaction will speed up. The substrate fits into the active site, but only the right substrate and the right enzyme will match. If you've got the wrong substrate, it doesn't work. That's why they're called specific. Heat them up too high, they denature, and that is a permanent change. Even if you cool them back down again, it is still broken. And that is the basics of enzymes.